burglary cases have risen significantly, with more than 16,000 reported in 2019, creating a growing concern for citizens and small businesses, especially in urban areas. Law enforcement has responded with task forces and increased patrols in high crime areas, but citizens are adopting advanced security systems such as cameras, motion sensors, and smart locks. Between 2019 and 2024, Malaysia's home security industry grew steadily, as can be seen from this graph. Modern security system faces several issues. On one hand, affordable systems often lack IoT features like remote monitoring and real-time alerts, limiting their effectiveness. On the other hand, high-end systems, while advanced, are complex and difficult for average users to navigate. Additionally, the high cost of advanced systems makes them inaccessible to many households and small businesses. A balance between affordability and advanced features is essential for effective, widely accessible security solutions. As such, this project aims to combine face recognition with QR code scanning offers stronger security. I aim to implement a QR code authentication system that's a constantly generated QR code, enhancing security by allowing only authorized users to access the lock. The second authentication method is face recognition, which serves as the primary security authentication method, where users must first authenticate their QR code and only then they can authenticate their face. There's also an app-based monitoring and control. It is an app that enables users to access QR code, which is essential to unlock the lock. This app also allows users to track their lock activities, though only limited to their own activities. This is the flowchart, which shows how users interact with the system. So the process begins at the login page, where users with no account register by providing details, while existing users input their credentials. Upon successful login, users are directed to the dashboard to scan the QR code. If the QR code is invalid, they are prompted to scan again. The system checks if the user's face is registered. If not, they are directed to register their face. If registered, face verification starts with a timer. Successful verification authenticates the user and locks the activity, while failed attempts end the process once the timer expires. This ensures a secure multi-layered authentication process. These are the components that are used in this project. So first of all, this an ESP32 with camera module, which costs 28 ringgit. This an Node MCU, which uses ESP8266 chip, which costs about 9 ringgit and 50 cents. This servo motor, which costs 4 ringgit and 50 cents. And this the Raspberry Pi 4B 4GB, which costs 240 and 90 cents. And the total cost about 282 and 90 cents. This is the UML diagram. It shows the integration of hardware, server-based service, and an app to create the security lock system. The ESP32 captures image and then sent to a localhost server for display as a video feed. This video feed is processed on the Raspberry Pi 4B, validating both QR codes and face recognition. If a face is not registered, the system allows for face registration. The Raspberry Pi also hosts MySQL database and Laravel API to store user and generate QR codes constantly while logging activities. The smartphone app provides a user-friendly interface for registration, login, and a dashboard page that has a QR code and activity logs. The Node MCU is connected with a servo motor to simulate door unlocking based on QR code or face verification. And this is how the product looks like from the inside, the back, and the front side, which shows the OLED display and the ESP32 cam. Thank you.